In this example, we have given the graph of function f. Okay, so we have given here the graph of the function f over here as like a kind of green curve. You can see that over here, right? And the graph of the function g is given over here as a blue curve, right? So that's what we have given here, which is function g of x. So these are the two the graphs of the function given. Our goal is to, looking into this graph, we need to see if we can evaluate the limit of what limit. It looks like we need to evaluate the limit of the sum of these function f of x and g of x, right, and at 2. So that's what we need to figure out. We need to figure out the limit of that sum of the function f and g at 2. So let's try to do that. All right, so how can we begin with? So as you know that on this problem we have given the sum of the two function, right? So our goal is to find the limit of f of x plus g of x. These are the sum of the two function. We need to find the limit of this, but we know that by the sum rule we can actually find the limit of sum of the function as sum of the limits of the function. What does that mean? Well, that means just find the limit of the function f at 2. That's what we need to find it, right? Find the limit of the function g of x at 2. Okay, so whatever their limits are, just add them together, and that's what the sum rule says. So just find the limits of the function, right, and add them together. That's it. That's the sum rule. But how can we apply that rule over here to find the limit? To use that rule, we need to know what is the limit of the function as x gets closer and closer to 2. So if that is the case, let's look into the graph of f, right? So which is given over here, right? So on this green curve, and let's try to see when on the x-axis, whenever we go closer and closer to 2 from the left, let's go closer and closer to 2 from the left, and then also from the right. When we do that, you can see here how the height of the curve or the y value behaves. This is actually getting closer and closer to somewhere over here. And what is that location? This is actually corresponding to, it's look like this is 4 and then that is 6, and what could be that location? Is it 4.5? Yep, that's what it looks like, right? So if that is the case, then we can just write down the limit of the function when x gets closer and closer to 2 is actually 4.5, right? So we just need to see when x gets closer and closer to 2 from the both side, if the y values behave the same way and then approach to a same number or not. If y value approach to a same number, then that would be the limit of the function. In the same way, let's try to find the limit of the function g here when x gets closer and closer to 2 from the both side, right? So let's go closer and closer to 2 from the left side. Let's go closer and closer to 2 from the right side. When we do that, the height of the curve is actually determined by this blue curve over here. So we need to go closer and closer to that. The y value will go closer and closer to this location from the left, and then the same thing over here, right? So it's happening also from the right side, the same behavior. Let me write down in this way. So this is the location we are going from the both side. All right, so that's what happening. What is that one? Oh wow, oh, coincidentally again we get the 4.5. So that's nice, no problem, but don't expect always the same type of behavior for the both function, because it depends on their own behavior, right? So their individual behavior. On this case, both of the y values either for the function f or g, both of them approach to 4.5. That's just a coincidence, but our job is just now to add those limits and then see what is the limit of the function. 4.5 plus 4.5 is 9. So this is the limit of the sum of the function f and g.